Hello everyone, I'm your TA. And today we are going to solve this question. The question asks us to find the minimum distance between the line y equals x plus 1 and the parabola y squared equals x. So first, what does this question look like? Drawing on the xy plane, we can see that the line y equals x plus 1 looks like this, and the parabola looks like this. And obviously, there is some point here and here, such that the two are closest to each other. So the distance of this orange line is the minimum distance. Now, but how can we write it mathematically? We can consider the function f, a function of x, y, and uv. And why can we do this? Since here we view a point on the line called it x and y, and the point on the parabola we call it uv. And so the distance, the square of the distance, is just x minus u squared plus y minus v squared. So this is just the square of the distance. But however, there are some constraints. The two constraints are just the two equations of the two curves. So the first constraint is y equals x plus 1, and the second is u equals v squared. These are the two constraints. So the question, we can write it again. So f equals x minus u squared plus y minus v squared. And the two constraints, we can call it, the first we can call it g. So g equals x minus y plus 1, and this constraint is equivalent to g equals 0. And also we define h, we call it u minus v squared. And according to this constraint, so that the point uv is on this parabola, it is also 0. So this is the function we want to minimize, and these two are the constraints. According to this form of the question, we know how we can solve it. We can use the Lagrange multiplier method. The Lagrange multiplier method tells us that when f attains an extrema under these constraints, there exists some constants lambda g and lambda h such that gradient f at this point syuv equals lambda g gradient g plus lambda h gradient h. So this is a equation. However, this equation tells us 4 different equations, since there are 4 components of the function f. That f is a function of x, y, u, and v. So in fact, this is 4 equations. So first, we need to take we need to calculate all the gradients. So gradient f, according to definition, is partial f, partial x, partial f, partial y, partial f, partial u, and partial f, partial v. And evaluating by chain rule, the partial x, partial f is 2x minus u. And for the y partial derivative, it is 2y minus v. And for u, 2 minus x minus u. But since there's a negative sign, we have to add a negative sign here too. And the last one is minus 2y minus v. So this is gradient f. And similarly, we can calculate gradient g. Taking the x derivative, it is 1. Taking y, it is negative 1. And for uv, since g is not a function of u and v, the last 2 components are 0. And also for gradient h, it is 0, 0, and for u is 1. And for v, it is negative 2 by the power rule, negative 2v. So the Lagrange multiplier method gives us the 4 equations. The first is for the x component. So this 2x minus u should be equal to lambda g times this, the x component of gradient g plus lambda h times the x component 0. And the other 3 equations come in the same way. So this is for the y component, lambda g times negative 1 plus lambda h times 0 here, negative 1 and 0. And for the third component, the u component, we have negative 2x minus u equals lambda g times 0, since here is 0, and plus lambda h times 1. And for the v component, again, equals lambda g times 0, this is 0, plus lambda h times negative 2v. Yeah, negative 2v. However, there are 4 equations. However, we cannot forget the other 2 constraints. So constraints give us that x equals y. Oh, sorry, y equals x plus 1, and also the other u equals b squared. So here we have 6 equations, and there are 6 unknowns. These 6 unknowns are x, y, u, v, and the 2 lambdas. So 6 equations, 6 unknowns, and we know that we can have a unique solution. So now let's solve it. Okay. First, we should simplify it a bit. So it becomes 2x minus u equals lambda g, 2y minus v equals negative lambda g, and negative 2x minus u equals lambda h, and negative 2y minus v equals negative 2v lambda h. And also the 2 constraint, we just write it down again. So these are the 6 equations. For convenience, we label it as 1 to 6. Okay. Now, 6 equation, we can solve it. However, solving it is really seems really scary, since wow, 6 variables, 6 unknowns. How can we solve it? However, when we are solving these kind of equations, we have better look for some patterns in it. And after we find out these patterns or these clues, it is much easier to solve it. So for this case, we notice that the equation 1 and equation 3, they are both this term, 2x minus u. And these 2 equations both need to hold. So from 1 and 3, we obviously get lambda g equals negative lambda h. And also, from equation 2 and equation 4, since there's also a common term, 2y minus v, 2y minus v. So obviously we get negative 2v lambda h equals lambda g. Or, like first we can write it this way. So this is by 2 and 4. So we can pick out these 2 relations from the 6 equations for the lambdas. And obviously there are 2 main cases we can consider here. And in fact, there are exactly only these 2 cases. So the case 1, the first case is that lambda g equals 0 and lambda h equals 0. That they are both 0. And these two equations are naturally satisfied. And for the second case, if one of them is not 0, like for lambda g, if lambda g is not 0, and then according to this, we have lambda h is not 0. And also, since lambda h equals negative lambda g and they are both not 0, we have lambda g not equal to lambda h. So these are the only 2 possible cases for the solutions. So let's do it case by case. For the first case, case 1, we have lambda g equals lambda h equals 0. And plugging this into the 6 equations, from the first equation, we see that lambda g is 0. So 2x minus u is 0. So x equals u. And also for the second equation, since lambda g is 0, so y minus v must be 0. So y equals v. And the third and the fourth equations just tell us the same information. And for the 2 constraints, we still have y equals x plus 1 and u equals v squared. So we need to solve for this. It's much easier now, since these 2 are just trivial. So this one, y equals x plus 1 just become v equals u plus 1, since y equals v and x equals u. And for the last one, it is just u equals v squared, So plugging this into the upper one, we get v equals v squared plus 1, okay? And rearranging v squared minus v plus 1 equals 0. Then according to the quadratic formula, the solution for v is just 2 and -1 plus minus I square root of 3, which is imaginary. However, notice that since u, v, and xy are points on the xy plane, so they must all be real. So, and hence, this solution, this case, is unacceptable. Unacceptable. Since all the unknowns must be real, and this is not real. So the only possible case for this solution is case 2. Lambda g not equal to lambda h not equal to 0. In this case, we can also rewrite the equation set. But first, we just look at these two. So we get lambda h equals negative lambda g, and negative 2v lambda h equals lambda g. Or the first one, we can write it as this. And obviously, we find that these two are the same. These two are the same. So negative lambda h equals negative 2v lambda h. But since lambda h is not 0, lambda h is not 0, so we can divide both sides by lambda h. So we find -1 equals negative 2v. And obviously, v equals a half. And by the second constraint, we have u equals v squared. And v is a half, so naturally, u equals v squared equals a quarter. U equals a quarter. Okay, so this is the first part. Now we need to solve for x and y. How can we do this? Take a look at these equations. From the first equation, we see that 2x minus u equals lambda g. And from the second equation, we can see that 2y minus v equals negative lambda g. So, obviously, even though we don't know what lambda g is for now, we know that these two are just, if we add these two together, this is just 0. So, x minus u plus y minus v equals 0. It is obvious. So, x plus y equals u plus v, which is u a quarter and v a half. It is 3/4, 3/4. So we have x plus y should be equal to 3/4, and also the last constraint, equation 5, we have y equals x plus 1. So now 2 equations and 2 unknowns, we can solve for x and y. Plugging the second one into the first one, we get x plus 1 equals 3/4. So 2x equals 3/4 plus minus 1, which is negative 1/4. So x equals negative 1/8. This is x. And for y equals x plus 1. Here, y equals x plus 1. So y equals negative 1/8 plus 1, which is 7/8. So this is the solution. This is the solution. And obviously, we have seen that these are the only solutions to this set of equation. And according to the graph, we see that there is a distinct minimum point, a minimum distance here. So the minimum case must be this. So f of xy uv with this must be the square of the minimum distance. Yes, this is according to the Lagrange multiplier method. But what is this? So this is what we call that f is x minus u squared plus y minus v squared, which is, so this value is just this minus u squared plus this minus v squared. And this is just this. which is 9 over 32. So this is the square of the minimum distance. So the minimum distance is the square root of this, which is, and if we rationalize it, the denominator we get 4 times 2, 8, 3, and square root of 2. So this is the minimum distance we need to find, and this is the answer. So from this so what do we learn from this example question? First, when we see a problem with minimizing something subject to the constraints, we must first think of the Lagrange multiplier method. And after listing out all the equations, we should find some clues or some patterns in it. Like for this case, we figure out the 2 yellow ones and the 2 green ones, and separate it into several cases, and discuss with these cases. And finally, we'll get some easier way to solve this huge sets of equations. So this is the main idea of solving Lagrange multiplier method questions. However, this question can also be done by some ways other than the Lagrange multiplier methods, and I'll show them in the following, but I will not explain them focally. So this is the first alternative method. And for the second alternative method, it is this concludes the video. Thank you for watching.